Hello, Georgi Romanic here. Today I'm going to talk about unit vectors. Unit vectors are absolutely basic building blocks of vectors, vector analysis, coordinate systems, and anything related to vectors. So without any further ado, let's go and describe unit vectors. I will start with a nice right-handed Cartesian coordinate system, x and y axis, and a generic vector A. I will decompose this vector and I will for now concentrate only on the x direction. So this over here is what we call AX component of vector A. Now, let's say that the x-axis has some measurement units and let's say it's meters. You will see soon, it doesn't really matter, but just for the sake of argument, let's say this is in meters. And over here is 1 meter. Let's say this is 2 meter. Clearly this would be 1.5. This would be half a meter. What would be AX component of vector A? Well, AX component of vector A would be 2 and unit is meters. But this is not enough because AX is a vector. If I make this a vector, this is not enough because 2 meters is scalar. So I need to multiply this with a vector in order to get result that is a vector. And this is where we get the notion of unit vectors. I will multiply this with a unit vector I. Now I have result that is vector that has magnitude 2 meters and the unit vector I gives the orientation and sense for this vector AX. And clearly I could do the same thing in the Y direction if I choose to decompose this and get my AY direction. So unit vector I is in the X direction, and here we would say we have unit vector J that is in the Y direction, and there is also unit vector K that is in the vertical or Z direction, but for simplicity I only included 2 dimensions here, X and Y. Now please notice that intensity of unit vector I is 1, but there is no units associated with it because units are in the part that describes the magnitude. And to prove you that the intensity of unit vector is always 1 regardless of the coordinate and the units, I will plot right here another x-axis and another y-axis, in other words, another coordinate system, and I will have the same vector A right here. I will get my component AX. But let's say this time I invent some crazy units, DRM. DR meters, that's my contribution to science in this video. And let's say DR meters that don't exist. Here is 1 DR meter, here is 10 to the 9 DR meters, here is 3 DR meters. So completely crazy. And here is, let's say, 7 DR meters. What is AX component in these crazy units? Well, AX component is 7 DR meters times, again, unit vector I. And you can see that I have the same unit vector regardless of the unit I am using to measure the component of vector AX. Therefore, we say that unit vector in X direction, which we call I, has components 1, 0, 0, unit vector j in the y direction has components 0, 1, 0, and the unit vector k, which is in the z direction, has components 0, 0, 1. These vectors, as you can see, are also independent. And that means if I make a progress along the I direction, I am not making any progress along j or k directions. And the same works for any combination of these three. That also means that any vector A can be written as a linear combination of these three unit vectors or base vectors. So this was a short story about unit vectors. I assume most of you already knew about these things, but for those of you that didn't, I hope this video helped you to better understand the building blocks of vectors. Now at the end of this video, I would like to share with you one discovery in my life that I wasn't aware about before, but completely changed the way I see things around me. To do that, I need my well-known experimental platform that is right here. You see, for years and years, I used these teaspoons, and you know, sometimes you have jar that is like this jar of sugar, and you have this small teaspoon, and you can't, it's difficult to get things that are deep enough if the jar is very deep. And then a few weeks ago, 2-3 weeks ago, I realized there are teaspoons that have a long handle. And believe it or not, I wasn't aware that thing exists. And now, look at this. I don't know who is the person that figured out to put a long handle on a teaspoon, but this is one of the best discoveries in my recent life, and I believe this person absolutely deserves Nobel Prize. This is absolutely amazing. I cannot imagine my life anymore without teaspoon with a long handle. Absolutely amazing. I recommend that you get it. You will not regret it. Until next video, goodbye.